Now so far we have seen the pair of lines specifically passing through origin, but in general if we have a pair of lines not necessarily passing through origin, then how to find their joint equation, right? And it is nothing but the same concept that we saw in the beginning of this chapter. So if we consider the two equations as two general forms, a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then their joint equation will be the multiplication of those two expressions. So that is uv equal to 0, isn't it? So on multiplying we will get lot of terms in the expansion. So there will be one x square term, xy term, y square term, and the terms in x, y and the constant term as shown here. So we see that all those coefficients we replace with simpler symbols. For example, the coefficient a1, a2 of the x square term, we write it as simply a. Okay. Similarly, we replace all other labels with the simpler symbols, and finally we get the general second degree equation in x and y. You see, this is not a homogeneous anymore because all the terms are not of the same degree. If you see the first three terms, they are of second degree. Then the next two terms are of first degree because they are the terms in just x and y. Whereas the last term is a constant term. So we can call it as a 0 degree term, isn't it? So therefore, it is a general equation of second degree in x and y. Alright, so that represents any general pair of lines. Now let us solve one example related with this general equation of any pair. Find the joint equation of pair of lines passing through the point 2, minus 1 and parallel to 2x square plus 3xy minus 9y square equal to 0. So by the wording parallel to this, it means that if you see the equation given, that represents a pair of lines through origin. So we want two other lines which are parallel to the lines in this given pair, and they also must pass through the point 2, minus 1. So if you want to roughly draw a sketch of how the lines might be looking like, so the point 2, minus 1 will be somewhere here. Now the given pair can be represented as some pair of lines passing through origin. Now we want the pair of lines which are parallel to this given pair, so therefore I am drawing them parallel, right? So this line is parallel to this and this line is parallel to this, likewise, and the point is 2, minus 1, right? So what is the equation of this new pair of lines? Now from the given data it is clear that if we know the slopes of the two lines in the given pair, the same slopes will be of the required pair of lines also, right? So therefore let us simplify this given equation. Now we can see that we can easily factorize that because the product is minus 18 and sum is plus 3, so clearly it is plus 6 minus 9. So therefore on simplifying we get 2x square plus 6xy minus 3xy minus 9y square equal to 0. So therefore taking 2x common, we have x plus 3y, and taking minus 3y common, we have once again x plus 3y equal to 0. So therefore we have x plus 3y minus 2x minus 3y equal to 0. So clearly the slope of the first line is minus 1 by 3 and the slope of the other line is plus 2 by 3. So now we have got the two slopes and now we know the point also. So using the slope point form, we can get the equations of the two lines and then multiply them to get the joint equation. Okay. So let me first write the two slopes here in the side so that we can clear the screen and then write the equations. Right. So let us now write the equation of the line which has slope minus 1 by 3. So that is y minus -1 is equal to m into x minus x1, correct? So therefore that gives us y plus 1 multiplied with 3, so that gives us 3y plus 3 is equal to minus x plus 2. So therefore we have x plus 3y plus 1 is equal to 0. This is the first line. Let us find the second line. Here now we write y plus 1 is equal to 2 by 3 into x minus 2. So therefore we have 3y plus 3 is equal to 2x minus 4. So therefore now we have 2x minus 3y minus 7 is equal to 0. So therefore now merging these two, we get the joint equation as x plus 3y plus 1 into 2x minus 3y minus 7 equal to 0. Right. Lastly now we have to write the final equation. Now for that you see it's not really needed to write all the terms one by one. We can even mentally calculate the final equation. We know that in the final equation there is going to be an x square term. So how we will get the x square term? That is by multiplying the individual x terms in the two expressions. So that gives us 2x square. Now next let's think about the xy term. How shall we get the xy term? The x part in one and the y part in the second, whereas y part in the first and x part in the second. So that gives us minus 3xy plus 6xy. So that gives us plus 3xy. Then we have the y square term. Clearly we will get it only by the product of y and y. So that gives us once again minus 9y square. Now let's think about the x term. So that will be nothing but x into constant and constant into x. So we get minus 3x plus 2x, sorry, minus 7x plus 2x, that is minus 5x. Okay, then the y term is y into constant and constant into y. So that gives us minus 21y minus 3y. So that gives us minus 24y. And lastly the constant term will be obtained by the product of both the constant terms, which gives us minus 7 equal to 0. So that's the final answer. If you see, interestingly, the first three terms, that is the x square, xy and y square term, are exactly same as the original equation. So that also brings us to an important point, that since the lines are parallel, you see the angle between them will remain the same. Or looking at it from the other way around, in case even if we were given a general equation and asked to find the angle between the pair of lines, that will depend only on the first three coefficients. Right? That will not depend on what are the coefficients of x and y and the constant term.